here's number 2. So first one, pretty straightforward. You're bringing down the power, multiplying by the number in front, which will give you negative 6/5. And then reduce the power by 1, which will give you negative 3/5. And then we don't want negative exponents in our answer, so we're going to transfer that to the bottom. This is like a preset fraction, so you got your negative 6/5. Technically, you could put the negative in either spot, but not in both, because then they'd cancel. And then this comes down to the bottom, becomes positive 3/5. Second one is a pretty standard quotient rule problem. So we're going the second times the derivative of the first minus the first times the derivative of the second over, oops, sorry, didn't mean to cross that out, over the bottom squared, and then we're going to FOIL here, so 30x to the 7th. Outsides will give me negative 4x to the 4th. The insides will give me 75x to the 4th. And then the last is negative 10x. And then 6x squared times 3x to the 5th is 18x to the 7th. And distribute that minus, so it's minus 18x to the 7th. This would be negative 6x to the 4th, but it'll end up being plus 6x to the 4th. All over the bottom squared. And then if I start combining like terms, I'm going to have 12 of the x to the 7ths. I'm going to have 77 x to the 4ths. And then the minus 10x is just left over. And the bottom stays squared. All right, number 3, this is a product rule. So I got the first and the second. So the derivative is the second thing times the derivative of the first thing, which is just 15x to the 4th, plus the first thing times the derivative of the second thing. So the derivative of ln of something is 1 over the thing times the derivative of that thing. So that gives me a fraction, which means I'm going to have to do some common denominator work here in a second. This I would simplify and say that's a 2 on top and an x on the bottom. So 6 divided by 3 is 2, x over x squared is x. And then you got the 3x to the 5th plus 1 on top also. And you need a common denominator to add these up, so I need to put an x here, which means I need to put an x up here, which will give me 15x to the 5th on top, times ln of 3x squared over the x. And if I distribute here, 6x to the 5th plus 2 over the x. And then you can just, add those straight across. So 15x to the 5th ln 3x squared plus 6x to the 5th plus 2 all over x. Sorry about my zooming there. I might have messed up number 2 also. So there's number 2, just big picture, because I'm not sure if I zoomed it okay. And then here's number 3, big picture. And again, feel free to pause, rewind. Number 4. So the first one is product rule. So second thing times the derivative of the first thing plus first thing times the derivative of the second thing, and I'm plugging in 2 in this one. So g is 4, f prime is negative 3/2, f is 2, g prime is 1/2. So that's negative 6 plus 1, which is negative 5. Second one, that's quotient rule. So g times f prime minus f times g prime. It's just f over g squared, and now I'm plugging in 1. So g is 2, f prime is negative 2, f is 4, g prime is 2, and that's all over 2 squared, and that comes out to negative 12 over 4, which is negative 3. Number 3 is chain rule. So bring down the 2, leave the little guy alone, reduce the power by 1. That's a 1, not a prime. And multiply by the derivative of the inside. And then we're plugging in 1. So 2 times f of 1 is 4. F prime of 1 is negative 2. If I multiply those together, I get negative 16. Number 4, you take the derivative of the big guy, you leave the little guy alone, and then you multiply by the derivative of the little guy. So this becomes f prime of g of 3 times g prime of 3. And this is a composite. This is not a multiplication. So g of 3 is 3. So then I want f prime of 3, which is 0. And then times g prime of 3. Doesn't really matter what that is, but that is negative 1. When you multiply them together, you're going to get 0. Number 5, we're going separate sheet here. So we would have x to the third plus 2 to the 1/5, and then negative 2x minus 1 to the negative third, because we didn't bring it up top. Alright, so product rule, and then we got chain rule inside of it. So the product rule is the second thing times the derivative of the first thing. So 1/5, leave the little guy, reduce the power, multiply by the derivative of the inside. So that's your 2 and your d1, and then plus 1 times d2. So bring down the negative 3, leave the little guy, reduce the power by 1, and multiply by the derivative of the inside. Then we're going to start making this into fractions. So that 1/5 kind of tells me, okay, that splits it for me. So there's a 1 on top and a 5 on the bottom. I don't need to write the 1. There's a 3x squared on top. And then these two are both negative exponents, so they're both going to go to the bottom. And the exponents will become positive. Over here, I've got negative 3 times negative 2 on top, so 6. This is a positive exponent, so it stays up there. And this will go to the bottom and become to the 4th. So I got a couple things to take care of. I've got 3 of these here and 4 of these here, so I'm going to need 1 more of them over here. So I'm going to multiply by negative 2x minus 1. So now I'll have 4 of them, which will match. If I multiply the bottom by that, I got to multiply the top by that. And then the other issue is this guy. He just doesn't exist over here. So I'm going to go x to the third plus 2 to the 4/5 over here. And to the 4/5 up top. And the nice thing there, and it always should work out this way, is when you multiply those together, you'll add these powers and you'll get 1. So kind of clean it up here. Let's distribute while we're doing this. So negative 6x to the third minus 3x squared over 5. Oh, I forgot the 5. Okay. I need a 5 over here too. So there's going to be a 5 here, which means I need a 5 up there. Alright, getting back over here, we have 4 of these now. We have 4/5 of these. And then I have 30 times x to the third plus 2 over 5 times these chunks on the bottom. So now if I'm going to combine like terms, so I'm going to have 30x to the thirds from here and negative 6 from there, which I mean I have 24 of them. I'm going to have a negative 3x squared from here. And I'm going to have a 60 from here, 30 times 2. And that's all over that same stuff that is still on the bottom. Alright, moving on to number 6. Again, I'm going to rewrite it. So I have the negative x to the third plus 5. That's to the 1/5. And then x to the 4th plus 3 to the 1/3. So no negative exponents at the start of the problem. But we will get some when we take the derivative. So 2d1, 1d2 again. So the second thing times the derivative of the first thing. So bring down the 1/5, leave the little guy, reduce the power, multiply by the derivative of the inside, plus. So that's your 2d1. Now we're going 1d2. So 1 times d2. So bring down the 1/3, leave the little guy, reduce the power, multiply by the derivative of the inside. Now let's start doing fractions. So I got a negative 3x squared over 5. That's what these two tell me. I've got x to the 4th plus 3 to the 1/3 on top because the power is positive. Negative x to the 3rd plus 5 on the bottom because the power is negative, so it flips to the bottom. Over here, I've got 4x to the 3rd on top and 3 on the bottom. That's what these two tell me. This one goes on top because it's a positive exponent. This one goes on the bottom, and the exponent becomes positive. So now I've got a couple things to worry about. The first is this 3 and 5 don't match. I want to make them into a common denominator, so I'm going to use 15. So I need to multiply this by 3, and therefore the top by 3. Same thing over here, I need it to be 15, so I multiply the bottom by 5, and therefore the top by 5. Also, this does not exist over here, and it needs to. So I'm going to multiply by negative x to the 3rd plus 5 to the 4/5. If I do that on the top also, these will add up, and I'll just have one of those. Same thing going back the other way. I need this piece to be here. So therefore I have to put it on the top also. And then these will add up to 1. So the next step, just kind of cleaning things up, I'll have negative 9x squared times x to the 4th plus 3. And now it's just to the first power. And on the bottom now I have 15. And then now I have both of these chunks here. And both of these chunks are in both parts. So here I have 20x cubed times negative x to the 3rd plus 5 over the exact same denominator. So this distributing on the left-hand fraction will give me negative 9x to the 6th minus 27x squared over, I'm just going to say blah, blah, blah for now. And then this will give me negative 20x to the 6th plus 100x cubed over, I'm going to say blah, blah, blah. And then I'm going to combine them and reinsert the blah, blah, blah. So I'll have negative 29x to the 6th, 100x to the 3rd, negative 27x squared, all over 15 times x to the 4th plus 3, no, sorry, x to the 4th. Yeah, these should have been 3's. X to the 4th has a plus 3. I kind of messed that up, but that doesn't really affect the problem too much. Hopefully that wasn't an issue. I apologize if it was, but there's your answer. Number 7 is another product rule. I'm going to rewrite this one also. I guess not rewrite for any reason, except I just want more space. I'm not like getting rid of a negative exponent or a radical sign or anything. So it's product rule. 2d1. So the second thing times the derivative of the first thing. So that's going to be cosine of 5x squared times 10x. So that's my 2, and that's my d1. Plus 1d2, so plus sine of 5x squared. And the derivative of cosecant is negative cosecant cotangent times the derivative of the little guy, which is 25x to the 4th. And then in these spots, the little guy stays in both of those spots. So that's the derivative, but you can only have one term in your answer. So I'm looking for chunks that I can take out. So there's a couple of ways you could have done this. I'm going to start by taking a cosecant of 5x to the 5th out of both, which would leave me here with 10x times cosine of 5x squared, and here with negative 25x to the 4th, so I'm taking that negative and that 25x to the 4th, times sine of 5x squared times cotan of 5x to the 5th. And if you had stopped there, I would give you credit. You could go a step further. So the cosine is that you got a cosine in this term and a sine and a cot in this term. So the trig functions are done. There's no more factoring you can do there. But with the 10x and the 25x to the 4th, you could take out a 5x, which will give you 2 times cosine of blah, and then 5x cubed times the rest of these trig functions. And I would have accepted either one of those, either one of these two steps for an answer. Number 8, so the derivative of secant inverse is 1 over the absolute value of the thing being secant inversed times the square root of the thing being secant inversed squared minus 1 times the derivative of the thing being secant inversed. So really all you had to do was throw this up here on top. And this would be your answer. I somehow during the test started marking this negative sign wrong. And I think I got to everybody that did that and I marked them wrong. But if you have this on your paper and I marked it wrong because it's negative, please come show me because I shouldn't have marked it wrong. The second thing here is don't get rid of this absolute value sign. So a lot of people got rid of the absolute value sign and made the negative 3 or positive 3, but the x to the 5th needs to be absolute valued also, so it's just a lot easier just to leave those signs there and don't mess with trying to simplify it. Number 9, another product rule. I heard a couple people say they thought this test was harder than the last one, and I don't disagree with that. I'm not controlling that, really. I'm just hitting modify the test, and whatever will be, will be. I don't think it was unfair. I just think it was a little more difficult. But with 3 attempts at it, I'm not going to feel too badly about that. Product rule again. Function of x, function of x. So the second thing is cotan of 3x squared times the derivative of the first thing. So the derivative of e to the x to the third is e to the x to the third times the derivative of x to the third. So there's your 3x squared. Plus the first thing times the derivative of the second thing. So the derivative of cotan is negative cosecant squared of the 3x squared, and then times 6x. And that's your derivative, but we can't have two terms. So again, we're going to look for chunks to take out. This is kind of similar to the last one. I for sure can take the e to the x to the third, and then you may or may not have taken the 3x with it. If you look at these two, you could take a 3x out. So I'm going to do them both, but if you just did the e to the x to the third, it's okay. So I did e to the x to the third, and then the 3x, and pulled that out. And if I pull that out of this one, what's left is cotan 3x squared, and then just an x. So if I took 3x out of 3x squared, there's an x remaining. And then here, there would be a negative cosecant squared 3x squared, and a 2, because if I took a 3x away from 6x, there's a 2 there. And that would be your answer. All right, one more, the implicit. So the derivative of 4x squared is 8x. This requires product rule, and I would look at it as 4x squared and y. So the second thing is y, the derivative of the first thing is 8x, plus the first thing is 4x squared, the derivative of the second thing is dy over dx, and that equals 0. You guys did a much better job today of not leaving the 2 there, but instead remembering that the derivative of 2 is 0. Now I'm going to, so this is already over here, so I'm going to move that over the other side and that over the other side. So 4x squared times dy dx equals negative 8x minus 8xy. Then you're going to divide by the 4x squared. Those cancel, and that's your answer. Some people went a step further and took out a 4 and an x, which would leave you with negative 2 minus 2y over x. But either one of those are acceptable. All right, hopefully that helps. Until next time, click on my link or something. Good luck. Email me if I can help.